Okay, so we're going to be looking at the next section, which involves the area for triangles, trapezoids, and rhombi. Hopefully you already know the area of a rectangle, which is going to be base times height. So we can make a triangle just by cutting this in half. And notice that this right here is our area for a triangle. It's 1/2 of any rectangle that we can make. So that's why we say that the area of a rectangle, or sorry, the area of a triangle is equal to 1/2 base times height. Now, just like with the parallelograms, we want to make sure that we're careful that the height is perpendicular to the base, and some triangles are tricky. Now, with a right triangle, it's real simple, right? We just have the base and the height and the base, both the same thing. But with any triangle that's not a right triangle, such as this, then we have to make sure that we have that distance of height. For a trapezoid, we have basically a rectangle in the middle with two triangles coming off of the sides. That looks like a trapezoid. So that would be the area. Well, let's write it here, right? So here, I'd have this area of the rectangle plus this triangle plus this triangle. Actually, one way that we can think about this, or we could say that this is 1/2 the height times the sum of the bases. We could work this out algebraically, but we don't have to do that. And then we also have a rhombus. A rhombus, we're going to need the diagonals. So actually with a rhombus, we get all these little triangles, right? 4 little triangles. So with a rhombus, we're actually going to use those diagonals in there. So the area is going to be 1/2 of the first diagonal times the second diagonal. That's the length of diagonal 1, length of diagonal 2. Oops. Just can't get that straight. There we go. So we could say that this is D2 and D1. Doesn't matter which one we call which. So let's look at some problems. Here we have a triangle. So the area is going to be 1/2 base times height. So this is 1/2 the base, which is 7.9, times 3.5. So we get that the area is equal to, we could do 1/2 times 7.9 times 3.5, and we end up getting that the area is 13.825 meters squared. Don't forget that meter squared again. Here we have a trapezoid. So the area is equal to 1/2 the height times the sum of the bases. So this is 1/2 the height, which is 4, times 5 plus 1.6. So this ends up being 2 times 6.6. So we get that the area is 13.2 kilometers squared. Here we can see that the first diagonal sum is 10. The second diagonal sum is 8. So the area for this rhombus is going to be 1/2 of their product, 10 times 8. So we get 40, and whatever that unit is, units squared. Similarly, for this next one, we see the first diagonal is 14. The second diagonal is 10. So we get that the area is equal to 1/2 14 times 10. So we get 70 units. Whoops. Units squared. All right, here we have another word problem we can take a look at. So Jacques is designing a window hanging composed of 13 congruent rhombi. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think, what, 4, 7, 10, 13. Yep. So there are my 13 different rhombi. The total width of the hanging is 15. That's this distance here. That's 15. And the total area is 82 7/8. That's a horrible number. Square inches. We want to find the length of each diagonal and the area of one rhombus. Well, these are all congruent, so that's going to help us out. We know that the total area is 82 7/8. So I'm actually going to convert that to this right here, 82 7/8. This is going to be 663 divided by 8. And that's a little bit better. Or we could work with decimals. I'm going to work with fractions here. So this 663 over 8 is the total area. And this is equal to 1/2. Well, this is equal to 13 times 1/2 diagonal 1 times diagonal 2. So, because they're all congruent, we can divide this by 13. So I could multiply both sides by 1 over 13, so I get 663 over 8 times 1 over 13 equals 13 times 1/2 diagonal 1 times diagonal 2 times 1 over 13. Here the 13s cancel. And here, 13 actually goes into 663. So this reduces to 1 and 51. So we get 51 over 8 is equal to 1/2 diagonal 1 times diagonal 2. This is the area of one rhombus. So the area of one rhombus is equal to 51/8 inches squared. If you do want to make that into a decimal, or you are working with decimals, that's 6.375 inches squared. So that's the first part. Now we want to find the length of each diagonal. Well, notice that the length going across cut through 1, 2, 3, 4, 5. So this is 1 diagonal, 2 diagonal, 3 diagonal, 4 diagonal, 5 diagonal. So I can call them each diagonal 1. So that means that 5 diagonal 1s equal 15, so diagonal 1 must be equal to 3. Then I can combine these two and say, well, 51 over 8 is equal to 1/2 of 3 times diagonal 2. So that's 3/2. So if I do 51 over 8 times 2/3, that's going to give me diagonal 2. That's 1, that's 4, that's 1, that's 17. So diagonal 2 is equal to 17 over 4ths, and these are both in inches. So just to recap, just to summarize, given the total area, all we have to do is divide that by 13 because there are 13 congruent rhombi. So you get the area as 51 over 8, or 6.375. Knowing that the width is 15, I can see that there are 5 diagonals here, tip to tip, to make 15. So I divide that 15 by the 5 to get 3 inches. Plug that into my area formula, and I get that the second diagonal must be 17/4. So a nice little question there, just, applying everything. But make sure you do know all the formulas for these 3 types of polygons and how to find the area.